Welcome to the third in this series of short lectures on the subject of statistical process improvement and statistical quality assurance. These lectures are structured around the six-step process-oriented quality assurance cycle that appears in Table 1.1 of Vardaman and Job, and we are to the point of discussing step number 2 and the corresponding tools that appear in that Vardaman and Job text. That is, we're to the point of talking about customer-oriented measures of performance and corresponding measurement systems. In quality assurance contexts, measures of performance need to be customer-oriented. At the end of the day, we're attempting to provide value for end customers, and our measurements, our metrics, the things that we keep track of, need to be as directly as possible related to the desires and the needs and value for those customers. It's often possible to measure things that are perhaps related but not directly representing customer needs and value, but it's always best, if possible, to measure things directly. So if one wants to know how satisfied a customer is, it's always better to ask rather than to try to infer by, for example, finding the amount of company money spent on warranty claims. As we begin to think about measurement or collecting data, we're immediately taken to the subject of metrology, or the science of measurement. There's some basic terminology that we need to establish here before going any further. One important term is the term measurand. The measurand is a true or correct value about which one wants to gain information. The truth is that one very rarely knows a measurand perfectly. That is, there is almost always some measurement error associated with trying to determine the value of a measurand. A measurement never perfectly reflects a measurand. So a measurement Y rarely perfectly reflects its corresponding measurand X. This might be illustrated in this simple picture or diagram, this cartoon, where a measurand is seen only through a measurement device producing a measurement, and Y is not necessarily exactly equal to X. In fact, it is rarely exactly equal to X. In this discussion, we're going to use the word device to stand for all that goes into producing the value Y of a measurand of interest. So it will involve equipment, how that equipment is used, personnel, how data are recorded, and so this notion of a device here is a very broad one, extending beyond device pictured here as a simple ruler or a scale or something like that. So our device, our understanding will be broader than this picture, but this picture is a nice cartoon for reminding us that measurement involves error. Some basic issues in metrology are validity, precision, and accuracy. These are words that have similar colloquial meanings, but they have much different meanings technical meetings, and we're going to keep these ideas, these concepts straight and separate as we talk about them in this course. And if you're taking IE 361 at Iowa State University, you're going to need to keep track of these things separately for course purposes. Validity of a measurement system means that the system really tracks what is intended. If I'm trying to measure acidity, I'm not measuring temperature of the room, for example. Precision has to do with consistency of measurement. It means getting values that are alike when I do remeasurements, when that's possible. And accuracy means that I'm getting the right answer on average. It's perfectly possible to have for example, a bathroom scale that is very imprecise. That is, as I get on it multiple times, I get a fairly wide range of weights for myself, but on average, it produces the correct weight for me at a given time. So here's a simple analogy that should help you keep straight the difference between at least precision and accuracy. It's a target shooting analogy. When I shoot at a target, I can be on target or off target. I can be at the center of the target, or I can be off center. These are targets that where I've shot near the center. There I'm shooting accurately. Over here, I'm not shooting accurately. I'm shooting high and to the left. On the other hand, for these targets, I have a wide pattern. I have a lot of variation. While for these targets, I'm shooting fairly consistently. So the top targets would represent imprecision. The bottom targets would represent precise shooting. Both precision and accuracy are things that we will concern ourselves with. Again, precision has to do with consistency. Accuracy has to do with being on target on average. Good organizations put significant resources into maintenance of their measurement systems. They do both studies to make sure that their measurements are accurate. Those are usually known as calibration studies. And they do studies having to do with measurement precision that are sometimes called repeatability and reproducibility studies. We'll talk a bit about both of those kinds of studies. They concern two of the three important issues of measurement.